All right, we're going to take a look at the question on that uses the stock solution of the FeTiO3. So it was, one part of the longer question that we did from our titration lecture. But let's take a look. All right, it says that we're going to build a stock solution containing the compound FeTiO3. All right, and in order to build this stock solution, we're going to put a certain amount of grams of compound into solution, and it says that we are going to start off with 4.33 grams of this compound. All right, so if that's what we're going to put into this solution here, we want to figure out, okay, well, how many moles is that? Because that's a more useful number for calculations. Grams is what we use in the lab, but moles of it is what is going to be more of an application to solving for other values. So my conversion across the top, I'm going to make the diagonal match. All right, the conversion factor for moles and grams is always 1 mole is periodic table grams. So if you go and add this molar mass up on the periodic table, you're going to get 151.72. Multiply and divide, and this is going to give me or for those of y'all, I've been told that y'all like to watch it on the camera, the work. So 4.33 times 1 divided by 151.72. All right, and I'm going to get 0.0285, and that is moles of the FeTiO3. All right, cool. So now I just know how many moles are in there instead of grams. And what I can do is I can figure out overall molarity, since we, of course, know that molarity is moles over liters. All right. If you go back to the problem, you'll see that it tells you the volume, the liters of this solution that we dumped it in. And it's 965 milliliters. So what I want to do then is divide this mole count by the liters, which is going to be 0.965. And that's going to give me, I'm going to bring this number over here. All right. Or here, we can draw a little arrow because it's cute. All right. That's going to give me 0.0296 molar. That's the molarity of the stock solution. And now we're ready to start the problem, and it says, okay, well, we're going to use this stock solution in a greater equation. You can see the equation in the problem, all right, reacting with chlorine and carbon. And it tells us how much of the sample, or rather what we're going to take, how many liters or milliliters we're going to pull out of this to start our reaction. And the value that it gives is 0.01575 liters. All right, there's this many liters of FeTiO3. So there's my starting value, and now we can start going through our titration process where I can't start with liters. I need to start with moles as we analyze the reaction. All right, so we're going to go from liters to moles. I'm going to make these diagonals match. All right, I know that my moles and liters is the same thing as molarity, so keep in mind that while we can use molarity as the unit there, it's also moles per liters. They're synonymous. So this is telling me that there's this many moles in 1 liter. So 1 liter of this solution that we're using, this compound with, contains 0.0296 moles. All right, so if we run this, 0.01575 times 0.0296, all right, I get that number right there. 4.66 E negative 4, or your calculator might have said 0.000466, whatever. This is a much nicer way to write it, though. All right, and what we have found at this point is moles of the FeTiO3. All right, so there's our first step of our titrations. All right, so now I know that we need to turn moles of what we know into moles of what it's asking for. So we're going to go moles to moles. And if you go back to the question, you'll see that the part of the equation that it wants us to analyze is chlorine. So that's what we're going to be going to. I'm going to make my diagonals match. Whenever moles is being compared to moles, stoichiometrically, I know that it's the coefficients that we're going to use. So again, you need to look at the problem that we're copying from, and you'll see that the coefficient for the Cl2 in the balanced equation is 3, and for the FeTiO3, it's a 1. All right, so again, we'll do a little arrow to make my work look like it makes sense. And as I solve this, I get 0.00140. And now I've got moles of chlorine. And then looking at our last step of titration, I know that once I have moles of unknown, I can go to anything. If you look at what it's asking for here, it says determine the concentration, which is the same thing as molarity. So we'll go back to our molarity equation, moles over liters. It turns out that we've already got the moles, so I'm going to take the 0.00140, and we need to divide that by liters. And again, go back to the question, and it says that the ending volume dealing with our sample is going to be at 320 milliliters. So we're going to be dividing it by 0.32 liters. For a final answer of 4.37 E negative 3 molar.